Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing exponential functions. This is standard A.9D in the great state of Texas, and we are using item number 52 off the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have these 4 different graphs, and one of them is going to match to this little problem situation we have up here. So this is going to be an exponential function here because we're increasing at a rate of 6%, and hopefully we know the way our graph looks like this is it does look like it, at least in the positive sector, it moves up really quickly. And so let's make sure we understand what an exponential function looks like. This is going to be our best bet right here. Y equals a times b to the x. And so let's define these terms real quick. So the a term, if we're dealing with investment, compound interest, which this initially looks like it is, but it's not necessarily that context, but it's going to be your principal. It's going to be the initial amount that you deposit, and then your interest compounds annually. For us, we're going to say that a better way to describe this is your initial amount. This A term is going to be your initial amount that you either invest or it's worth, or in this case, we have this initial home value of $200,000. Okay? So that A term is going to equal 200,000 because it tells us A equals 200,000, but for our purposes, we also know that this is going to be your y-intercept. We know it's your y-intercept simply because that's where the function crosses the y-axis, right, when x equals 0. What happens if I plug in a 0 here? A times b, and I'm going to replace the x with a 0. Well, b to the 0, anything to the 0 is simply 1, so that's just a times 1, which means when x is 0, y equals a. So this a is also my y-intercept. So that's very helpful because now I can look and say, all right, F, we're looking good, but look at G. G's got that y-intercept of 100,000. I can immediately discard G. H is a possibility. J, I can discard that. It's gone. So I've already eliminated 2 answers. And that's very helpful. So let's look at B. B is your rate, and it is a growth rate if it is greater than 1, which in this case it is, right? It's 6% greater than 1, and then it's a decay rate if it's less than 1. Now that 6%, if we turn that into a decimal, right, is going to be 0.06, which is less than 1. But remember, when we're talking about a growth rate, that's just the rate that it increases each year. We always have to keep the initial amount in there, and that's just the one whole. The one whole is that 200,000. So it's 6% above the 200,000. So when we're talking about a rate like that, we actually have to add a 1 back into it. So it's 1.06. So that's our B. Our B term equals 1.06. So if we wanted to, we can say Y equals 200,000 times 1.06, and then your x is going to be each year. Okay, so that's going to be your step, and a lot of times it's going to be a time factor. In this case, it's every year, right? So now we can do 2 things. We can either plug it into the calculator, or we can actually do a little bit of math, and we can see what happens when x equals, let's take a look at 10, and see what happens when x equals 5, and plug those in real quick. So when I made this x 0, well, we know that's going to be your 200,000. When I made it 5, that becomes a 267,000, that's 645, and then when I made it that 10, becomes over 350,000. And as we look here, obviously this F is going to look a little bit better. This H is way too steep. 5 is not even on the graph there. So this F, these numbers line up with what we have plugged in, so that is our answer, F.